Hi everyone, in this video I'll be sharing about preparation of alkyl halide from alcohol. This is from the chapter Haloalkanes and Haloarenes, and here I'll be discussing about the preparation of alcohol from alkyl halides and its mechanism. So from alcohol. There are different methods to prepare alkyl halide. Okay, so here we are going to discuss about from preparation from alcohol. Now let us take alcohol first. Alcohol, the general formula of alcohol is, the general formula of alcohol is R bond OH. Okay, so this is your general formula. So this is your alcohol. What is this R? This R is called your alkyl group. How to know alkyl group? In order to know this is your alkyl group. How to know your alkyl group? First we have to know alkane. First we have to know the simple alkane. All the alkanes like CH4, C2H6, all these are alkane. So now if I just remove one of the hydrogen, then it becomes as bond CH3. So this is now your alkyl. So alkyl, and this is your alkene. Now this alkyl, what is the name of this alkyl? Since this is methane, okay, this methane, this will be your methyl. So in this way, you can just remove one of the hydrogen from the ethane and it will change into C2H5. So it is called your ethyl. Okay, so we should know what is alkyl first, what is alcohol, how do we identify alcohol. Whenever we see R bond OH, okay, then we know that this is alcohol. What is alkyl halide? Whenever we see R bond X, this is called your alkyl halide. What is this X? This X is your halogen group. So all these things should be clear first, okay, then the reaction becomes easy. Now see, alcohol we have started, then we have added the reagent, concentrated HCl, anhydrous, that NCl2. Anhydrous means which is free from the moisture, which should be completely dry. Okay, so this reagent is called your Lucas reagent, that is concentrated HCl plus anhydrous at NCl2. This reagent is called your Lucas reagent. So alcohol, when it is treated with the Lucas reagent, it forms alkyl halide. See, then water. Let us see the changes. See, on the reactant side, this is your reactant side. On the reactant side, there is alkyl. Let us see on the product side, there is also alkyl now. What is changes here? The changes takes place here. OH. The OH has changed into Cl. From where the Cl has came from? This Lucas reagent Cl. Now let us also learn this reaction in a very easy way. See, ROH. Let us separate it into positive and negative part. Oxygen being negative, we will say that this is your negative part, OH is your negative part, and this is your positive part. So in this way, same. Let us see your reagent now, HCl. Okay, in this HCl, see, this is your positive, this is your negative. So we will just replace your negative part by another negative. So R is still there. This negative part is what? OH. What is the negative part here? Cl. So we will just substitute your negative part, okay, by another negative. So here it is Cl. So it becomes as R bond Cl plus H2O. So this is your positive, this is your negative. So see, we have replaced one negative by another negative though. So this type of reaction is called your substitution reaction. Okay, we have just substituted one by another. So since this is minus, so this is called nucleophilic substitution reaction. So in this way we can learn the reaction also. Let us also learn the mechanism of the reaction. So mechanism of the reaction. What is this mechanism? Mechanism means the path where the reaction brings to product. Okay, from the starting to the product, how it has brought to the product. That shows the mechanism. So we'll start with the alcohol ROH. Okay, alcohol ROH. See, this ROH, oxygen carries 2 lone pair. It carries 2 lone pair. And this we will take this Lucas reagent, this anhydrous jet NCl2. Okay, now this oxygen carrying lone pair, this will behave as a Lewis base. Okay, this will act as a Lewis base. And ZnCl2, this is a deficient of electrons, it is a Lewis acid. So one is deficient, the other is electron rich. What is Lewis base? Which has the tendency to donate electrons to the electron deficient. Okay, and this is having the tendency to accept because it has deficient of electrons. Now this oxygen one lone pair will try to form bond with this. Okay, cool. will form bond with this. So in this way, see, R is still there, do not change the structure, R is still there. Okay, now oxygen, oxygen, then I will just put this ZnCl2, and I will bring this oxygen hydrogen downward. Lone pair, one lone pair has already utilized, another lone pair is still present. This lone pair belongs to the oxygen itself. Now it has bonded with Zn, so one belongs to oxygen, the other belongs to Zn. Okay, now see, so oxygen is losing one electron, so it is positive, and this gaining one electron, so this is negative. So in this way, oxygen carries positive charge and Zn carries negative charge. Okay, now this oxygen being carrying positive charge is very unstable, so it will always try to attain the stability. Okay, oxygen with positive charge is very unstable, so it will always try to attain stability. Stability how? Let's see. So this bonded electron pair will be shifted to here, to the oxygen, and now this will be cleaved as, will break as R plus. Okay, the total bond, this bond has shifted towards it. Now oxygen carrying positive charge will be neutralized, so OH, okay, ZnCl2, this, okay, OH, ZnCl2, this will still carry negative charge, but this oxygen carrying positive charge is neutralized by this bond. Now see, R plus is formed. R means what? Alkyl group. What is alkyl? Alkyl means carbon. Carbon carrying positive charge is called your carbocation. Is called your carbocation. There is an intermediate which is also very reactive species. So it will also try to react with Cl minus. From where the Cl minus came? From HCl. Okay, the Cl minus came from HCl. Now see, let's write in this form. So this Cl minus being negative and this being positive will try to form bond with R plus. Okay, always from the negative towards positive. So it will form as R bond Cl. Now our compound has formed, our aim has formed, that means alkyl halide has formed. Now what is remaining now? This part is remaining. This OH and this H will combine to form H2O, and now this ZnCl will form as ZnCl2. Okay, so in this way alkyl halide is formed. So this is the mechanism of the reaction, how it has brought into this, into the product. Okay, so this is the mechanism of the reaction. So how to learn this reaction? First you have to know what is alkyl halide, what is alcohol. See, I have just taken with R, but you can take with different you can take with different R, like alkyl group. You can start with CH3. Okay, you can start with CH3, OH plus. If you write the reaction, concentrate HCl, then anhydrous, ZnCl2. Then what we have to do? We have just to keep your R in its own place. Then we have to just replace your OH by Cl, and the remaining product is H2O. So in this way, this will give go on changing. Okay, this may be of branch type, this may be of, see, this is methyl alcohol. We can also take as another alcohol. What is that? Secondary alcohol. We can take tertiary alcohol. So there are different alkyl groups. So we will keep on changing this, and everything will remain fixed. So this part will go on changing, and whatever it is there, it will be fixed in any reaction of this type. Okay.